Hello, everyone.
Hello, Professor. How are you? Hello,
Uh,
Sava.
Hi, Jim. Hi. Uh, Today, the plan is to go attend the Rabin's presentation, right? So let's give 1 more minute. And thank you, Rabin, for staying late. I know it's midnight or 1 a.m., so I really appreciate it. Hi,
Yeah,
Camila.
it's
You
been
feel
like
Hi,
uh,
Professor.
so I appreciate the
thank you,
willing.
Professor.
Camila, do you know if Zorana will be joining us?
I am not sure, to be honest. No, I don't know.
Okay. 1 more minute, and then we can start. How about you start? How about you start, Rabin, and if someone joins later, maybe we will. I mean,
Okay, Vishal is asking for link. Let me send him.
and if you can talk about your overall picture and then the details, that will be great.
Okay. I'll try to summarize it and go through some details if necessary. For some time. So you have to allow profession.
Do you need permission to share or no?
Yeah. I don't have authorities to share my screen.
About now.
Is my screen visible there?
Yes, thank you.
Okay, so this is my presentation and the work that I am advancing towards and understanding the process with Professor Greg himself. So the overall presentation will be that at first I'll describe the brief application as well as some nuances regarding research, and if someone wants to go in detail and discuss, since it is a group discussion, so we can further move and discuss to the extent that I have knowledge about, and there are other things also that I have been developing and knowing in the process of learning. So that is the introduction part of the presentation. And to start it, let's go through directly the solution that we have developed so far, and this one is for the synthetic model. So basically, let's answer the most important questions of the application of this research. And what is the research first? This particular study deals with MMI scale intensity classification with the help of different parameter. Actually, we have planned to develop two models first. The first one is MMI scale relation with ground motion parameter, and that is PGA and PGV. So I'm working on the first model in this particular time, and the next model would be to classify MMI on the basis of site parameters like distance from fault or VS30. So those things would be included in that. Now let's focus on ground motion parameter, that is PGA and PGV. So what could be the application of the research? Talking about that, it would surely be useful to predict the PGA and PGV if we have a graph knowledge of MMI scale and its relation, and it can work as well in opposite direction. That is, if we have the PGA and PGV relation, either PGA or PGV from the instrument, then we can easily predict MMI intensity level of that particular location without setting our boots there. So this should give a rough estimate of what any site gonna experience the intensity of shaking on the basis of ground motion parameters. So that is the specific.
Rabin, can you talk a little, can you introduce what MMI is, just to make sure that again everyone is on the same page?
Could you please repeat, Professor?
Yes, could you please introduce what is the MMI scale before
Okay,
you
so
tell us?
MMI scale, its full form is modified Mercalli intensity measures. So what it does is whenever there is an earthquake happen and uh, mm, the ground shakes, particular location experience shaking and the destruction. So it is the subjective measure of intensity of shaking in the particular location. It is based on people's perception, how they felt it in that particular region, and how structure responds. So it is overall measure of the shaking in terms of response that people felt there, or the structure has been damaged there. So there are actually 12 classification measures that defines the MMI scale intensity, starting from first MMI first scale, that is no shaking or very small shaking, which most of the people could not feel or can't be felt, to the vigorous shaking of destructive damage, that is to the 12 MMI class. So those are the ranges that we will be talking about, and that is the particular thing that we will be modeling from the data we have, large sets of data that we have acquired. So that is the part. And on that aspect, the development that has been done is that we have first developed the synthetic model using some linear combination formula that you can see here, that has correlation, that has relation of MMI with PGV and PGA, and some random noise that we could get in the field. So with this particular formula and with some randomly generated motion features, the MMI classification has been done using Gaussian process classification method. So here the main math behind is Gaussian process classification itself, and we can see the ground truth MMI boundaries here that comes from the equation itself, and the boundary separation from the randomly generated data. So those boundary are very important because they define either my intensity lies in higher intensity or lower intensity region. It is not very effective in lower boundary, but if we move to a higher boundary, those density along with the curve. So this is the path of over R.
So maybe if sort of add one more layer of simplicity. So as Robin said, like MMI scale is a discrete scale of different outcomes that you get from earthquake shaking. So one outcome is that you felt the shaking, another outcome that it's knocked the furniture or like light furniture of the ground. More severe outcome was you had like structural failure, structural collapse. So all of these are different um, different not different numbers in the MMI scale, with one being the least severe and 12 being the most severe.
Yes.
And there is need to predict this if an earthquake happens so that people can focus their attention to certain areas that are more devastated. But it can also be used backwards, where if you have historical seismicity records where like someone wrote a letter that this big earthquake happened and destroyed my building, we can have an estimate of the level of shaking. And so there has been done work in the past, including the model that Rabin has at the bottom of the code. So where it says MMI continuous equals 3.5 plus 1.6 log PGA, and so on. Where these relationships give you the MMI as a function of PGA and PGP. And so Rabin treated this as truth and created the map that is shown on the left side of his screen, where it's like the different colors, the band. And then randomly sampled out of that, and those are the points that he's showing in the middle. And then he runs his own model trying to see how well he can recover this pattern. And it does a fairly good job, right? It's not identical to the figure on the left, but it's similar. One thing that Rabin is doing differently compared to what has been how this problem was solved before is that if you see that like this MMI continues, it's a continuous linear regression. So it will not give you the probability of different classes. It will just give you the value, the average value of the MMI for that PGA PGV. But this is, if you think about it, that doesn't make a lot of sense, because who tells us that this scale has a constant increment from size 1 to size 2? Like, if size 1 is you felt the earthquake and size 2 is no size MMI 1 is you didn't feel the earthquake, and MMI 2 is that you barely felt it, and you need like an increment of PGA of 0.5. Why should it be the same increment that would go from partial to full collapse? So that's why Rabin is trying to express the problem as a classification problem. Is there anything else to say? One more thing. Do you have some of your current results to show the challenge that we are currently having?
Yeah, we did try to model it with.
So before that, Rabin created this synthetic data set. Can you please go back?
Okay.
But there is one issue with that synthetic data set. Is it obvious to anyone what is the issue with how these dots are populated in space? Franco?
Am I missing something, or
Oh
have you
yeah,
said something?
or like no, if you can go on this slide, like, or anyway, I can say that it's the issue is this assumes that PGA and PGV are uncorrelated, and that's why they span the entire space. And this is not a realistic assumption. PGA and PGV are correlated. So when we are using real data that doesn't cover the entire space, we see that it's a much more difficult problem to solve. Yeah, you can continue, Rabbi, if there is nothing more to say on this slide. Or if there are no other questions. Are there any questions?
No.
Yeah.
How was the synthetic data generated then? Didn't you use a correlation between PGA and PGB? A model?
Can you answer that question, Rabbi?
Yeah, it is randomly generated from the range between -2 to 3.
Oh,
Yeah, just a random
okay.
value.
Okay. That's engineering for the
Yeah.
solution. Okay. Thank you.
And about 300 data were taken, and they were plotted accordingly to fit with this particular linear function that we have used.
Yeah.
Okay, is that clear? Maybe I'm having some issues with the internet. Hello, anyone?
We can hear you. Is this answer
Yes.
clear, Franco?
Yes. No, it was clear. Sorry, maybe you didn't hear me. Yes, thank you. Thank you, brother.
No, it's my internet. It goes sometime.
No problem.
Okay, then continuing that, I have tried to implement it with different approximation method of classification that is there. So in current period, I'm just trying with what approach best fit the respective value. So this is also done in the synthetic data, and this approach is called Dirichlet classification approach.
So can you tell us again what you're comparing between the top and the bottom line?
The same Dirichlet so it is something that I have tried one from the Dirichlet method, and this one is our similar data, but with standard approximation method of classification. And actually we have also tried it with real data, and yesterday only I got to know that there are some errors in the data that I have been using. Not errors, but those value must be cleaned before using, but I was using without cleaning since they are hidden beneath, and we have more than 3 lakhs of data, so I could not go through all of them at first, but I found out and I cleaned them, and there are some results before cleaning. And so these are some results that I have obtained from our own real field data of earthquake measure from 1980s, I think. Those were randomly sampled data. There are 50,000 data from them. There are some classification that has been done, but the problem was data itself, and maybe there are maybe there is problem with some methods and approximation that needs to be dealt with, but overall process that I have used is this is our standard process, and this is the Dirichlet method that I might describe in some time. So those are the classification from the real data. And so this is the part. If there is any question.
Are there any questions?
So in till this date, and it has been a learning curve for me. So what not to use, like discussing with professors. Those methods, and specifically how to do computation itself, because I haven't dealt with Gaussian process from the start. So it has been a learning curve to me, and I have been using induction point method, and that is also called sparse variational GP. It makes process faster, but what it does is we can see I have distributed our clean data in would get from the data, or group or MMI scale 9 is just 95. So from those data, it is picking the inducing point. So it might have been the reason that using the approach of inducing point have been very faulty here. As I also discussed with professor to implement better approach, but with fewer data if I could. So next model would be to implement with fewer data but from the real data sets, and using standard approach. And next thing that is important is to understand that our MMI scale is ordinal relation. So classification must obey that ordinal, or the monotonicity of the scale itself, because there is a probability of exceedance that if we have MMI scale value 3.5, then it will surely exceed the MMI scale of 3, but it will not reach to MMI scale of 5. So those will also define the boundaries that we will be getting in our model itself. So that also matters much. And there is something that I'm currently planning and figuring out and studying, and that is those MMI. I'm trying to correlate MMI with PGA, PGV, and in that part, I should also try to correlate their relation, because one affects another. So what I'm trying to develop in the next phase is taking MMI, PGA, PGV whole as a sets of input and finding the correlation between them through the mixing coefficient approach, or in some sort that we'll define or we'll find out in a process. But it is for sure that MMI, PGA, PGV are, they are correlated with themselves, because their source is same and the site that measures and that got affected is similar, so they are correlated. So there must be some correlation between them, that are only classification or the approach of normal classification could not handle those aspects. So the ordinal relation must be obeyed in the process. That is another, then there is one constant in our research study, and another is the correlation within data itself. So those features also I would like to add in the near future. And I have also tried to work on only one model, because there are various things I have been trying. I am trying with distillate, I am trying with standard softmax method. So I think I'll only go with the standard method first, using small sample data, and I'll try to correlate the relation within the data itself as well as obeying the ordinal relation. So this will be my future prospect of studying it in more depth.
Thank you.
So this, okay.
Um, are there any questions? Yeah, we can talk about that maybe in more detail in one of our meetings to understand what exactly your plan is here.
Okay, let
Um,
me.
okay. Is there anything else to discuss at this time?
Those are the overviews. I think that's it for now. And in the future meeting, if there will be a further development, then we'll talk about it.
Sounds good. Then we can keep maybe this meeting short.
Yeah.
And resume next week.
Yes.
Yeah. Okay. And thank you, Rabbi. Okay, then I think we will meet next week. And is there anyone who would like to share the results? Okay, I can find something to present myself. See you everyone in a week. Have a good weekend, and Rabbi Bisala will email you separately. Or maybe can you join? I will send you a Zoom link in a few minutes to talk. Okay.
Okay,
Okay.
Bhushan. That will be great.
Bye everyone.
Thank
Bye.
you.
Bye.